I want to see you.
Okay, so what are we doing here? This is volcanoes class, so it's got something to do with volcanoes, right? And I'm going to talk fairly briefly, and we'll talk more upstairs when we get back in the classroom about what this is about. There are some time restrictions we have here. One of them has to do with Professor Robertson gives a class shortly, 20 minutes, and the other thing is it's getting dark earlier, so we're lucky in terms of the way the weather worked out. And I'm going to talk sort of briefly about two aspects of what's going on here. The first one is physically what are we doing, and the second part is what are we trying to demonstrate here? What is this physical representation? What does it mean in terms of volcanoes? Well, physically what's going on here is this is what's called a tour flag, which is just kind of a fancy thermos. And you know how a thermos keeps things cold and keeps things hot for a longer period of time than the ambient temperature around it? Well, it's the same thing with a tour flag. In this particular tour flag, there is liquid nitrogen. And liquid nitrogen has a boiling point of about minus 300 degrees. So that means if there's liquid in there, as opposed to vapor, that means that it's minus 300 degrees or colder. You might have seen, you know, like Mr. Science type experiments where they take, somebody will take a banana and throw it in liquid nitrogen and pull it out with some tongs and smack it with a hammer and it shatters because it's instantly frozen. Minus 300 degrees, right? If it's liquid, it's minus 300 degrees. So that's what's going to happen in terms of putting something into liquid nitrogen. Notice that there is a cleaner tab on here, which is a port with a little hole in it. And what's happening is liquid nitrogen, even though it's in this container that's insulating, it's vaporizing, albeit somewhat slowly, it's still vaporizing. And that container would probably only hold that stuff for a couple of days before all of it vaporized.